Hi, I'm Anita Srinivasan. Today we see about the introduction of digital electronics. Digital electronics is represent the information with the values of zeros and ones. And this two values, 0 and 1, is called as discrete values. And we represent that 0 as no voltage and that is a 0 voltage. And we represent the 1 as a full voltage that is 5 volt. So 1 is represented as a high voltage and 0 is represented as a low voltage. And it will be used in a transistor with a switch and it will be high speed and it is a small in size. As a switch, if it is 0 that is the off and is 1 means it is a on. There is a difference between the analog and then digital. Analog system is represented with the time varying signals and that can take on any values across a continuous range of voltage and will be used in electric and electronic systems. The next is a digital. The digital system process a time varying signal that can take on only one of two discrete values, that is 1 and 0. So 1 is represented as on, high and true. 0 will be represented as off, low and false. The analog electronics deals with the non-discrete values and digitals or deals with the discrete values. There is a benefit of digital signals over with the analog signals. It is a reproducibility, not affected by noise, easy to design, data production, programmable, high speed and economy. The digital device, the different types of digital devices, that is a gates, flip-flops, PLDs and FPGAs. Now what is a gate? Gate is the most basic digital devices are called gates. Gates got their name from their function of allowing or blocking the flow of digital information. A gate has one or more inputs and produce an output depending on its inputs. Gate is also called as a combinational circuit and there are the basic of three different types of gates, that is AND, OR and NOT. The binary system is considered with the value of 0 and 1 and this is the basic blocks of the gates: AND gate, OR gate and NOT gate. What is the basic digital elements in electronics is a switch. Using switch to represent digital information, this is a circuit as a switch. So in the MOS transistor, the gate will be act as a switch. It is difficult to make idle switches, means a switch is completely on or completely off. So we are using some rules that allow analog behavior to be ignored in most cases. So circuits can be modeled as if they really did process as zeros and ones. It is known as a digital abstraction. Digital abstractions allows us to associate a noise margin with each logic values, zeros and ones. And this is the digital representation of the digital circuits with the gates and logic levels. And this is a digital logic which is varies from 0 to 5 voltage. So from the low voltage of 0, it will be decreases to 1.8, again at 3.5 and then 5 voltage. And this is a MOS transistor. We have two different transistor. One is a PMOS transistor and NMOS transistor. And the MOS transistor is a voltage controlled device. And next one is a CMOS inverter. The combination of the PMOS and NMOS is a complementary MOS transistor. And this is a circuit diagram with the value. The input voltage is 0. The transistor 1 is off condition and transistor 2 is on condition. That time the output will be 5 voltage. That is high voltage. The next condition, when we are applying high voltage, that is 5 volt, the transistor Q1 is under the on condition and transistor Q2 is off condition. So that time the output is 0 low voltage. So when we compare the input and output, when the input is low, the output is high. When the input is high, the output is low. So it will be act as a NOT gate. So this is a switch diagram for the CMOS. And next is a flip-flop. A device that stores the value either a 0 or 1 is called as a flip-flop. Its stored value can be changed only at certain times determined by a clock input. New value depends on the current state and it is a control inputs. A digital circuit that contains flip-flops is called as a sequential circuit. And we have here different types of flip-flops. The first one is a SR flip-flop, and then next is a JK flip-flop, and next is a D flip-flop. So all the design is going to be integrated in a single chip, that is the integrated circuits. A collection of one or more gates fabricated on a single silicon chip is called an integrated circuits, and this is classified with the different types along with the size. The first one is a small scale integration. It only contains a 1 to 20 small number of gates. The next is a medium scale integration. Next is a large scale integration, and then very large scale integration. So nowadays we are using a very large scale transistors. And these are the pictures of the ICs, the integrated circuits, which are AND gate, OR gate, NOT gate, NAND, NOR gate, etc. And these are the ICs number. 7400 is the ICs number. And next one is a programmable logic device. This programmable logic device allow the function to be programmed into them after they are manufactured. The next is this is to be divided into two types. One is a complex programmable logic device and another one is a field programmable gate array. This complex programmable logic device CPLD is a collection of PLDs on a same chip. But in a field programmable, that is another programmable logic chip which is to be defined as the FPGA. And this is a diagram for CPLD and FPGA. The next one is the application specific integrated circuits. Chip designed for a particular applications are called semi-custom ICs or application specific ICs. An ASIC generally reduce the total component and manufacturing cost of your product by reducing the chip count, physical size and power consumption, and which provide a higher performance. But it is costlier if not produced in a bulk process. The software aspects of digital design. Today the software tools are as an essential part of digital design. So for the software tools, it improves the productivity, correctness and quality of design. We are having some tools for that software. First one is a symmetric entry with the language of hardware description language. It will be designed. The next is a simulator. That simulator is used to verify the behavior of the design. The next tool is a synthesis tool. Here we are designing a circuit, and last one is a timing analyzer and verification. The digital design levels. So after the verification, it could be designed in a FPGA kit. The lowest level of design is this device physics and IC manufacturing process. Design at the transistor level, and the next is a functional building blocks. With the help of the hardware description language, it is moved to the logic design, and then the computer design and overall system design. Now we are going to be design a simple device, that is a multiplexer, step by step. Build a multiplexer with the two input data A and B, with the control input, that is switch as S, and the output is Z. So this is the transistor level circuit diagram. So gate is to be act as a switch. This is a truth table. The first S is a switch, selective lines, and then A and B is the input and Z is the output. So using a Boolean algebra for this logic multiplexer, the equation is Z is equal to X bar A plus S dot B. And this is a logic diagram with the two input lines A, B and one selective lines with Z is a one output line. And this is a IC diagram for the multiplexer. And using a very large scale, that is a hardware description language, first we are going to design a circuit for multiplexer. So with the multiplexer, we are using going to be start with the A, B and S selective lines and Z output. Let me see what are the diseases. Okay. Uh, the first one is a name of the program, and next is a type of PLD. Which type of PLD we are going to use, and then we are pin the number input numbers, that is A, B and S, and the output is a Z. And the equations, according to the equation, it is going to be done. So when S is 0, then Z is A, else Z is B. So in a hardware description language, we are going to be design, that is set the library values, and according to the library values, we are getting input and output ports, and then the behavior, functional behavior is going to be designed with the function of Z is equal to A when S equal to 0, else B. After completed, we are getting the input value, and then the signal is going to be act as a switch and produces the output data. And finally, the data designed is going to be implemented in a IC. So it will be used in a ASIC, that is application specific integrated circuits, because it design, that is minimizing the cost, and then the PLDs cost more but use the less PCB area. The mass production is avoided in the ASIC design, designed to solve real life problems. Yeah, that's all about our basics of digital electronics.